Hi my friends, today we model this bracket, ceiling bracket. Once again we use drawings from Timoteo Carrera Soto, and you already know where to find that drawings if you want to have for yourself. This part is simpler than the one in the previous tutorial, and we have to model it. I did this, and you can see here the model. Yes, and the drawing is here. You know that I create these drawings with all that details by taking dimensions from the original drawing and changing some of them to be just in time, in our time, not in Timoteo's time. We start by creating a sketch with all these profiles. Let's start, my friends. The plane is this one, YZ, and we start by creating two rectangles, 1, 2, having on the same vertical these 2 points, and also with a center point, but I place just in the center point. Dimensions are 20, 5, 500 and 200. This must be interrupted by using the well-known tool split. Why? Because we have here 2 lines and I want them to be construction lines, both. Good. Then this is this. Yes, this is the construction. And now we go to create these arcs and this offset. All of them will be presented without bosses and some holes, but the rest will be in this new sketch. Dimensions are all over here. Yes, 500 is from the upper face to the center of these arcs. 1, this one is another one, and this one is the last one. 40, 45, 47.5 and 72. I have dimensions and we create that lines. An arc, as I said, starts from here and goes here with a radius of 240. We place on the same horizontal the end of this arc with the center, because I continue with a vertical tangent. The other arc starts from here to somewhere here, and the radius is 330. And it is also finished on the same horizontal with this center. Horizontal is this. Horizontal from here is this. Why? Because Z is vertical always. I continue these two arcs with verticals, restart, and another vertical. The length of these verticals are taken from the drawing. You see, this one, for instance, finished here, and this point is at the center of 65. Our dimension is this one, 500. Minus 75 minus 5 minus 65 is this center and this line. Let's apply all this. Dimension, point, face or line, and as I said, 500 minus 75 minus 5 minus 65. 355. The other one, this one, ends at the level of this center. Yes, so that we subtract 75, 5, 45, 10 and 30 to be here. This line and this line ends on the same horizontal. Good. Dimension. From this line to this point we place values. 500 minus 75 minus 5 minus 45 minus 10 minus 30. This means 335. I'll place it inside to have an order here. Oh. My hand is still not very sure. From here you can watch my work and you will see how to create the sketch. at the end you will see how it looks, so that you can apply your order and your abilities to create that sketch. Be careful with each step because it is important. I made some mistakes here, I went back and so on, but you are able to create a sketch as you want. And it is not something very difficult, and I think you can do this. I change this value, double click on it, and I place 90. What happens? Where is my 90? It is here You see, this was not aligned with this. I delete this and I make collinear these two. Now we have fully constrained sketch. Good. You have your time to edit this sketch to create what you think it is important. Now we apply once again, not offset but split of this arc and this point, and also this arc and its point, fully constrained, yes? And now we make this as construction lines, entities, this one shift, and this one shift is pressed to apply construction. And now we draw lines to end this closed contour. One is this one, another is this one, another is this one, and the last is this one, my friends. Okay, finish sketch. If we take a look at the drawing, we see 1, 2, 3 dimensions. This width, this is 110, this is 60, and the smaller one is all with this dimension 45 on this side and the other side. What is the thickness? 10 millimeters. So 110, 60 and 10 millimeters. Good. Let's apply these extrusions. We start with the smaller one, which must be 10 millimeters. This is 10. Symmetrical about the midplane. Then plus to apply 110 millimeters, and not 110, 60 millimeters for all this contour. You see? Also symmetrical. Plus this one, which must be 110. You see? We have some closed contour, and we use them to apply different thickness. We obtain this. Very, very interesting. Now we apply this radius 10 at each corner of the plate, upper plate, and this 90 dimension here with all these fillets, radius 10 and radius 5 right here. Let's do this fillet of 10 at each corner. As you can see. Okay, then we make here another rectangle with a width of 90. Width of 90. And with the vertical is horizontal. Good. Finish sketch. Extrude. At the two ends. Cut all the way. Okay. Then fillets, 5 millimeters here, 5, and also here, plus 10 millimeters on the 4 sides. Not sides, edges. Okay. There is a fillet here, and the other side of radius 65. Again 65, so that we select the edge and we apply 65 and 4 places. Escape. Then we apply 20 in 4 places. Plus 5 millimeters on this thin feature. Okay. Okay. There are some unacceptable. Where are they? Here. Let's see what happens here. Five. We see this, but everything is symmetrical. I don't know what happens here. You see, 4.5 works. 4.9 also works. There is something unstable, but this not matters. Another fillet is this one, 70, but you will see that it is not possible to create because there is no room for it. I select this edge, I try with 20, it works, but if I place here 70, it doesn't work. So that I select this face, I project here this line, I make all of them construction lines, and I create an arc starting from this end going to this line with a radius of 70. I apply tangent between this end and this line. I draw manually one line to here and another one to the other end of the arc. Finish sketch. Now I apply extrude, to this end, but not as a part of this body, but a new solid. Okay, I change the color for you to see that this is another solid. Red is very good. Okay, now you see we have two objects. I apply an extrusion of this face. Yes, these two faces, but there is the same plane. With intersection, I create the sketch, I end the sketch. Then I apply extrude with intersection, but not for this object which is selected, you see. Let me show you what I do here. This is intersect direction, not that direction but this direction, and through all. Yes, with intersection, and I want to select this object, this one. See, now when I select through all, I have a new object made of two volumes. Okay, you see, this is what I have to add to the solid. I mirror these two volumes, which are only one object, solid 2, and I apply mirror mirror of the other object. I select a solid. I mirror a solid. Mirror plane is Z, Y, Z, and you see here that objects are present. Now I combine the two objects, selecting this as the first basic object, and the other is added to the first with join. Okay, now we have 70 millimeters as in the drawing. Next is this face with radius 20, radius 18, which is this face. Yes, we want to eliminate on this contour the volume of the part. We select this face as a base for a sketch, F7, and we draw a circle with the radius. Radius is already selected over 20. We make this tangent to this line, and vertical, which means horizontal, this point with the center, this center with the center point. Then I place an arc between these two lines with the radius of 18. I move this point to make tangent of this arc with a circle. It is tangent, and I suppose this is a common point. No, it isn't. It is. Yes? Good. Then the question is what dimension is needed? What are the dimension? I know what dimension. The dimension is a constraint, vertical between this point and this end point. You see? Now I project the Z axis. I make it construction to have no problem when we extrude, and mirror this arc about the midline, the center line. Apply. Done. Not done. Trim. Not only done, but also trim. Finish sketch. Extrude. And we select the two areas with cut. Not intersection, cut. Okay. Here is a hole of 20, you see. Let's apply hole, this face, this center, 20 is already selected, through, okay, good. Next we take advantage that we are here to apply this depression, spherical depression, 47.5 radius, and we use this detail. You know that these two are concentric. Yes, 30 is the distance between these 2 points, but we have already this arc to take the center. Look at me. I create a sketch in this plane. I apply project for this arc. Then a circle with a center in this center, which can be selected, with a radius of 47.5. Then I draw a line from this endpoint to the other diametral points. Trim. I trim this. I make this center line, and I have all the data to create that spherical depression with revolve and cut. Okay, very good. There is a boss here, and also 2 bosses here, and another one here. That's all we have to do. Next, the data are in the drawing. You see 80 millimeters is the button face, and diameter is 45, radius 20. Okay, plane, face, down, minus 80. Then we have to see what is the distance. The distance here is 67, you see. We draw a circle here in this plane. Circle with a diameter this time of 45, placed somewhere here, right in the center point. The projection of the center point is this, and if I project for you this circle, I can measure the distance, which is 67. Control Z, finish sketch. extrude to the part with join. Okay, this is to be not visible. Where is visibility? Here. And there is a hole of 20. Let's create that hole of 20. This is the face, this is the center. 20 is already placed, and I select this face for ending the hole, because I don't know now what diameters are the others. Good. Let's finish with this boss by applying a fillet of 20 right here. Good. Now we go to that two bosses. They are 1, 2. Dimensions are here. This one and this one. 35 is the first. I make them separately. 55 is the dimension of this one, and the placement is aligned with the hole here. Okay, we create a plane at a distance. The distance is 105 to this face. Yes, from this face to this 105. Plane up 105. We project here, we create a sketch, and we project F6 to see, no, F5 to see back. I project this circle here. Control Z, not the circle, the arc. I prefer the arc because I don't need to apply construction. 35 is the diameter. Diameter 35, and we extrude it to the part. Not, we extrude on 55, my friends. This is the good direction, and look here, it comes to up, but the distance is 55. Okay. Okay, with visibility, and we see here a radius of 12, so that we apply a radius of 12 here. 12 on this face and to the other. Okay, here is a thread. What thread? Metric 16, depth 35, 45. Let's apply this hole. Thread, ISO 16, not full depth, but let me select the face and the center. 32 is that one. We apply 45 here, tab. We don't change the conical end. We go here to 32 to place here 35. That's all. M16, 45, 35, okay. The same plane can be used for the next sketch. I make it visible and I select it as the sketch, F5 to go back, and I project this circle or a circle. I cannot select anything else because I have this. Yes, now I have a center here. What is the dimension? The dimension is 50, radius of 10, and this is existent, radius 20. Okay, and we'll see what about this fillet which is through. Good. Circle 50, extrusion to the part. Okay. Visibility 10. All over is 10. Okay. And the fillet, so the thread placed on this face, this center, ANSI united screw. I'm sure that this is not 7/8, is this one. Yes, it is 7/8 inches, and the end is on this face. Okay, full depth is the thread. Okay, now a boss here. Boss here, F5. We take a look at the drawing. We see diameter of 70 and 5 and 35. We draw a circle with a diameter of 70. We extrude it at 5. Extrude. 5 millimeters. Okay. Then a hole of 35. Hole not threaded through 35, placed on this face, on this center. Okay. We apply also fillet here of 10, and that's all. The last feature is to add these bosses 1 and 2 with their hole and fillet. Dimensions are here. See? Distance of 10. This is a slot. Yes? A big slot and a smaller one. The smaller one is the hole. Radius 25, radius 12.5, and distance of 10. Symmetrical on 420 with the other. Okay. We turn back the part. We select this face and we apply slot center to center, 10 horizontal and 25 multiplied by 2 because I have to place a diameter. Escape. You see here what we have. The other can be obtained by we place this on the vertical because Z is vertical with the center point which is present here. Okay, vertical for horizontal, this point with this point. Once again. Okay. Distance is half of that 420 divided by 2. We use dimensions in the drawing. We don't invent dimensions. Finish sketch. The height is 35 minus 20. Yes. Extrude. I have to select also this, and the distance is 35 minus 20. I create a new sketch and I apply offset. Offset of 12.5. Yes, let's see if this is okay. Yes, it is, my friends. Good. Finish sketch. Extrude. Internal contour through all. Cut through all. Okay. The radius is 5. 5. Okay. Now we have 3 features: fillet, extrusion, extrusion. To mirror about the vertical plane, which is XY, I suppose. Let's go here. No, XY. Okay. You see, we have here the replica. Now we take a look at the volume, because we finished the modeling. Update 265 and so on. Copy. Close. Go to the drawing. Double click on volume. And we apply that new value. Let's see how similar they are. They are similar. The difference is at the 4th rank. This is very good. We eliminate this because we use the last value here for you to have a target for your model. Okay, that's all, my friends. Thanks for watching. Bye bye.